We ending off the afternoon with Lorraine on wastewater reuse applications. Excellent.
Okay, so like I said, I will be presenting two case studies this afternoon. So the first one is reuse in the pulp and paper industry, and the second one would be reuse for potable use, and that's municipal wastewater. So the first one is a project where we partnered with NIAS in the Netherlands, and that was, like I mentioned, reuse for the pulp and paper industry. And it's a circular water concept and what they call the waterrotonde, which is in Dutch translated is a water circle, basically. So, so the challenge we had was there was 4 paper mills in the region of Eerbeek-Lunen, which were treated. Yeah, they produced wastewater, and the wastewater was treated by the Industriewater Eerbeek. And these paper mills were also facing some pressure to reduce their groundwater usage, and that is due to the fact that even though the Netherlands is below seawater, below sea level, we actually do have droughts there also. So basically the Industriewater Eerbeek treats this wastewater, and they are also facing some environmental challenges. So they have been asked to also reduce their impact and increase water reuse. So the mills, these mills operate in an ecological sensitive area, and that was the reason for that. So there was a motivation to develop what is called the waterrotonde, and with this water management system, we looked into different applications or different products to actually reuse this wastewater being produced. The vision, let me just give you a quick overview of the schematic here. So the 3 paper mills, which is these, the green blocks that you could see. So they all use well water, like I've mentioned. And this well water is being used to produce the paper, and the wastewater being produced then goes to the Industriewater Eerbeek site, where it's being treated to up to a point where the wastewater effluent has been softened, and then some of that water goes back to the River IJssel, and some of that water is then being reused in the factories again. So the idea was to make that a bit better and reuse a lot more of this water. So instead of discharging to the River IJssel, all of it would be reused. And that's where the circular water use comes in. So during the piloting or the demos that we ran, one of these water factories stopped operation. So eventually we only had two water treatment plants producing water going back to the Industriewater Eerbeek. So during the investigations, there was only the 2 the 2 paper factories that was producing wastewater. And during this total investigation, we also the partners investigated looking at how we can also deal with evaporation losses. And there came in that we would use some of the water from the River IJssel, as well as a smaller paper mill, which is this smart packaging solutions in Lunen, and also a nearby, also a wastewater treatment plant, RZWI Brummen, where we also actually did a pilot with nanofiltration. So, our approach. In 2023, they looked at the engineering design of this entire process. NX Filtration got involved, and this is where we decided to apply our DNF80 membranes. The pilot that we ran there was a Mexpert XL, so it had 8 modules installed, and the flow rate was around 10 cubic meters per hour, which we wouldn't really say as a pilot, but it's more demo. And the main objectives here was to demonstrate that all of these products can be used to meet the paper mill specifications. We evaluated the reject and the brine, the brine handling streams, and we had to provide design inputs for a full-scale plant. And that full-scale plant is 450 cubic meters per hour. So, how did we do that? So the entire process then was taking that softened water from the wastewater treatment plant and putting it through a 2-stage DNF system. So we used the concentrate from the first stream and reintroduce that to a second stage nanofiltration before it went for activated carbon and then electrodialysis reversal. So the main objective of the nanofiltration system was to remove your organics, like I mentioned earlier, your CODs, turbidities, color, also some solids, a little bit of your calcium and magnesium that was left over, and then some sulfates. That concentrate was further treated by coagulation and flocculation to remove the CODs, and then went back to the treatment plant. The concentrate from the EDI, the electrodialysis has also gone through ion exchange for hardness removal, and then the RO concentrate was also further treated. So we just mentioned a few advantages here of this entire system, and it was the fact that it was modular, so you could add modules, you could add any of the process steps as the plant grew further. Partial desalination, I believe that is part of the electrodialysis. Process is reliable, but we will see some of that in a little bit of the results. So just to visualize it, we've split the entire process into 3 main processes. So the first one was the water line, where the nanofiltration membranes were used, and there you could see at least the color of the samples that we've had at each step. So once again, taking the feed water through the nanofiltration and taking that higher concentrate, you could see the color is a bit more concentrated than the initial feed water. Taking that right through to the product water. The concentrate loop, so as I mentioned, coagulation, flocculation, and then through a centrifuge, obviously the centrifuge sludge is a waste, and then the centrate has been fed back to the industriewaterbeheerbeek. So the results, I mentioned earlier that we had one of the factories closed during while we were piloting, and even with that fluctuating feed, we still had stable membrane performance. So unfortunately, I do not have the flux and the permeability graphs here, but we are working on a paper that will be published before the end of this year. So that can also be distributed. So but mentioning that the feed water quality fluctuated, but we managed to recover the permeability and also the DPs during operation. The plant operated at a recovery of 90%, the nanofiltration plant, and a flux of 22.5 LMH, which is quite demanding, we would say. And COD removal rates of more than 90% was achieved, sulfate around 60%, and then your calcium hardness around 35%. And this was all with the DNF 80 membrane. So that is the 800 Dalton. So the more open membrane of the 2 products that we have. And then just the key takeaways. Like I've mentioned, it was a robust and stable performance with the membranes. The downstream processes they were performing quite well, we would say, because you've got a good permeate that you form, and you put that through your GAC and your EDR. So they operate a lot better, which gives you lower regeneration frequency on your GAC, and then in turn lower OPEX on both of those downstream systems. It's a scalable solution, and we've demonstrated a high recovery concept due to the hollow fiber nanofiltration concentrate recirculation along with the RO brine treatment. So that was the first one. I don't know if you have any questions. Oh, sorry, it is a BAC. Yeah, sorry, it was a BAC. It's a mistake on our side. Thanks. Yeah, I think it also depends on the feed water quality. So it's always something that we could run through a projection and see if there's a possibility, if it would be a feasible application for us.
I think you got about 90% recovery. I don't see the solids loading into this plant, but I assume it was quite low because it's come from the treatment process through a softening stage and into the NF. So the TSS would be pretty low. Hey?
Yes, exactly. Yeah, so the TSS would be treated upfront. That also gives us a better operation in terms of cleaning. Okay, if no further questions, then I'll move to the second one. Let's see. Yeah, so this one is indirect potable reuse with our hollow fiber nanofiltration membranes in Leon, Mexico. So it's a reference case, the world's largest hollow fiber nanofiltration plant for municipal wastewater reuse. And actually this morning I've received in my inbox where we've, a press release where we've secured the second phase of this project. So that makes it in total 34 MLD municipal reuse plant for drinking water, which is quite magnificent, I would say. So basically here is we've been approached by Ecuador, who is our partner in Mexico, to help them design. We help them with a membrane solution for municipal reuse for Sapal. And so the reason why was there's increasing droughts everywhere, like we've mentioned, but in Mexico, we've seen since 2023 to 2024, there's been a major, more than 80% of Leon's territory is in extreme drought. So, needless to say, they've reached day zero, actually, in the city of Leon. So I believe a while ago in Cape Town, we also nearly reached day zero, where we had to take 2-minute showers or so, and don't drink the tap water and so. But here in Leon, they've actually reached it, and I've spoken to some of those people, and they really did not have a single drop of water in their taps. So I think that is quite difficult to imagine for us. Well, in some cases we do have that. I'm talking now from a European point of view, but I know the challenges we also have in South African. So what happened was we've had quite a few quite a few factors contributing to day zero. It was extreme drought. There was no surface water available. The groundwater extraction was limited, and along with an increasing population and existing reuse practices was unable to alleviate this drought. They've reached day zero, and the city of Leon was looking at taking their wastewater, and they call it the new era, to actually use that wastewater for their city to be able to have drinking water available. So along with Sapal, like I've mentioned, they are the municipality of Mexico, the Mexican water utility that provides the water. Ecuador was they were the designer of the plant and and the partner of NX Filtration in the area. So I believe it was last year at Aquatech, we secured the first phase of the project, which was about 17 megaliters per day. And this is it was one of the press releases back in the time. So the construction that's currently ongoing. So the municipal phase 1, which is 200 liters per second, they are currently constructing, busy with the civils, and commissioning is upcoming. And then for the second phase, as I've mentioned, we've now secured the order, so that will probably be in the next year, also commissioned. We ran a demo plant there with our DNF80 membranes, and that was in 2022. And the reason for them going with the full scale was that demo plant operated really well, and they could see that this could fit into their existing treatment scheme. Okay, so like I've mentioned, it's the first phase was 200 liters per second, 3 stages, feed and bleed, and also more than 85% recovery. Second stage is an exact duplicate of that, and in future, this municipal project will serve as basically as just as a validation that IPR, indirect potable reuse, can be used for future. And look, it's not a new thing. We've been doing it all over. I think, I believe it's Namibia. I believe Cape Town is also now looking at, in the Fora project, also looking at that. So, okay, so the existing plant is, there's some pre-treatment, coagulation, flocculation, the primary sedimentation, and after you activate the sludge, another secondary treatment. And this is then where the upgrade would come in, taking that secondary sediment, that secondary effluent, passing it through a 20 micron screen, and then directly into the hollow fiber nanofiltration membranes. From there, it will go through oxidation, ozone, an activated carbon polishing step, and then being pumped to a reservoir where it will then hopefully mix with some rainwater and then distribute it to the drinking water plant, where it would be further treated and then distributed as drinking water. So, water quality, what we've achieved, turbidity removal was 97%. This was based on the pilot unit that has been run. Color was removed more than 80%. Here, the sulfates have been removed more than 80%. A little bit of aluminium, 65%. Chromium, also 93%. Your iron and your zinc was also removed. What we've shown with the pilot system was that it could be an energy efficient way to do indirect potable reuse, and again, we're avoiding chemicals, so no coagulants, no flocculants being dosed before the membranes. Obviously, with the previous steps, yes, but not with the membranes itself. Yeah, that is my end. Thank you.